Good evening, and welcome back to the weird and the wonderful with Strange Bones. That's me. Kiara, welcome. Sonia Nodia, di Derek Orifier, and Georgie and Edmias. Welcome, welcome, welcome. So, this is part 2 of Alive. It was the continuation of what we started in the last live that we did, which was all about some of the real science behind science fiction. And it proved to be pretty good. It was supposed to continue last night. Unfortunately, I discovered that while in my head I am 17, in reality, unfortunately, I am not. And overwork at the gym had me pretty broken. So yeah, I skipped last night because it was just too painful. But nevertheless, with that as my excuse, which is probably not a terribly good excuse, but it is the one we have, I will give you a quick recap, and we will do the startup as per usual. So we were talking about quite a lot of the things that popped up in science fiction, from warp drives to cloaking devices and more, and whether or not any of it is actually really possible. And as it turns out, some surprising number of things are not only possible, but have been done. And of course, there's quite a few out there that simply haven't been done. I do warn you that this particular live does get a little bit technical because it leans heavily on quantum mechanics and the like, which does kind of mean that some of the things are just a little bit outside most of us in terms of science. But we try to keep it as simple as possible, simply because it really is that complicated in some cases. But thanks to the wonders of the internet, we find simpler explanations which do help. Now, I am going to start off, as I always do, by pointing out that on this live we have but one rule: do not be rude, because if you are rude, we give you the boot. But that said, you can agree, you can disagree, as long as you're polite about it. We accept and encourage any and all comments. We enjoy hearing opinions, and we love having you guys on to give said opinions. So absolutely comment greatly, send a ton of likes, share, subscribe, do all of the good things to help keep the old channel going. Thank you very much to King Stoffel ZA for those likes. I appreciate it greatly. And with that said, I do hope you give your opinions as to what you think. It seems that warp drives are not possible at the moment, though they might be in future dependent on. We went into the depths of why space travel is such a problem in the last live, because really you can't do it without either having a huge amount of time, which extends into if you want to go to one of the planets somewhere in the Milky Way, you can expect your great-great-grandkids to be the ones arriving if you leave. So clearly that's a problem. So we need a way to fold space, and as it turns out, it's not so much space that you need to fold as time. And the real difficulty is you would have to keep yourself outside outside the moving, so you need some kind of a bubble around you that makes you not move, both for the acceleration issue, the deceleration issue, and the fact that by and large trying to travel through things that way will result in you being what they charmingly refer to as spaghettiized. If you were to use the clever technique of ducking through a wormhole or a black hole, you'll be about an atom thick and in a long thin strand, which means when you arrive you probably would be a little bit unhealthy. So clearly an issue. So space travel in a serious sense at the moment is not a possibility. However, through quantum entanglement, it might become possible, whereby essentially you create a situation where the there and the here momentarily are the same place and you simply jump between. However, the other issue as well is moving around once you get there, because there's not a lot to propel you in space, but an ion thruster might work. If you could get one to work, clearly that's something we have not yet done. The difficulty is the fact that, at least according to current science, you cannot travel faster than the speed of light. And yeah, even to get to some of the really close stuff will take several light years, which means to get there within sufficient time to be able to actually do anything other than die of old age requires you to travel a lot faster than we are capable of. Nevertheless, we are carrying on, and we're looking at a number of things. One of the greatest scientific fictional programs was Star Trek. Thanks there to King Stoffel Zere for the following. I do appreciate. The reason why Star Trek was so good was quite simply because what they did was they based everything on real science. So while it is not a possible thing to do yet, the theories at least are pretty good. So a lot of the science was, if you could, then what if? The other thing that we looked at, which was pretty damn cool, was the idea of the transporter room. Essentially what you're doing in that is you're taking an exact map of a person, dematerializing said person, and then rematerializing them according to that map on the other side. Thank you so much for the like there, Shady. The difficulty in that regard is you better get that map very correct. Peter, thanks for the likes and thanks for the follow. I do appreciate. Imagine, if you will, I create a wonderful map of you, and then unfortunately, yes, you are indeed, Slim Shady is back. Imagine you got a computer virus into your map. Yeah, that would cause all kinds of issues. Of course, if you could do something like that, medically speaking, it would give you quite a few really cool advantages. So, say for example, you lost a limb. If I had a image of you on file of what you were like when you still had an entire body, I could dematerialize you, rematerialize you with the new, with the old image, thus having, with a few extra, I don't know, components added, with your original limb. So there are options just in that scientifically speaking are quite fascinating, but of course we cannot do it. Another thing we looked at was the idea of that fancy machine that they had for making meals, where you basically have a whole lot of base material which is simply reformed into whatever the person asks for, which means as long as you had a reasonable supply of base material, you could simply go and say, well, I want a cheeseburger, and zap, you get a cheeseburger. Pretty damn cool. Can you do that? No. Unfortunately, not yet. Though you do get things like 3D printed foods. So people are working on quite a few of the Star Trek-y type things, which is really interesting. But that said, let's briefly talk spaceships. What kind of a spaceship would actually work for long distance space travel, assuming you could get the propulsion and the ability to warp to a place, assuming you were there? Well, there is a group that joins us. In fact, I'm waiting on a couple of the guys to join in that do discuss a number of these things with us. And what's nice is we don't all agree or disagree. So we do talk on a number of the topics. So yeah, we actually do that. And there are a whole lot of things. Now, a lot of the info that I get it's stuff I've researched. It's not my opinion. I have opinions on these opinions, which I do give my thoughts on as well, as do the others. And there, in fact, is the man in question, Spooky Stream of Thoughts. And we are going to absolutely invite him to join in, because here's the other big proponent. Thank you so much for the like, Spooky. He's the other big proponent on this for what isn't possible, could it be possible, and all of the rest of that. So hang on to your hats for the second half. We got a ton of stuff to go through. It's looking like it's going to be pretty damn cool. Spooky, how are you?
Hi,
Are you
good
in good?
evening.
Yes, are you in good form?
Yeah, I'm good.
Fantastic. Yes, I'm sorry I missed last night. I went to training, and in my head I'm still 17, but my body has informed me that this is a total lie. I am not. And yeah, I was just so sore I went to bed and passed out. So
Okay, but it's probably nice to be nice and fit.
in my head I'm nice and fit. Does it count?
It does.
Okay, because in my body it's not quite as fit as I would like to be. And yeah, I'm still in quite severe achage. I've been trying to, well, I don't know if I mentioned before, I train in karate as my sport, my hobby. I'm not terribly good at it, but I enjoy it. But I've also was asked by somebody locally to teach the Anglo-Saxon staff fighting techniques, which I can do. And so I've been training up on that as well, and in addition, to get myself back into a bit, ready to teach a bit of it. And yeah, there's muscles that I haven't used for a while that are commenting, shall we say, vociferously.
Okay,
Yeah. But
so
yeah,
you don't train a lot.
I train about 3 times a week
That's a
in
lot.
general. 4 times now. I plan on more.
For but what, 45 minutes a day or something?
It's about an hour and a half for the formal training, twice a week. And then on my own, I would say I put in about 45 minutes. Sounds about right.
What do you do? Just kick into air?
Well, you've got a mix of things. When I do the karate stuff, it's the forms and all of that. When it's the staff stuff, well, you have to spin and manipulate the staff. So whether or not you have an opponent, it's more or less the same, I would say.
Okay.
All the spins and the blocks and the strikes and what have you. So yeah, the legs are sore, the arms are sore, the back is sore, the hips are sore.
But it's a good thing.
It is. It really is. It's a very, very good thing. And yeah, it keeps me fit. I mean, as pointed out the other day, and I had actually not realized it, I'm 54. I mean, bloody hell.
Okay, you're still young.
I'm glad you think so. Tell that to my knees. But yeah, working on it, working on it.
Well, I'm turning 36,
There you go.
but I might die before you die.
Why?
I'm very unhealthy.
Well, I try to be healthy. I had a nasty shock when I became diabetic and I spent a week in a coma. So that sort
I
of made
spent
me
10 years in a
rethink.
coma.
Yes, but that was voluntary.
Eh? No,
Was
me.
no, really? Are you
Really?
serious? Oh, wow. That
Yeah,
must have been harsh.
it was.
I mean,
Not a coma, but I was disabled for about 10 years.
wow. That's pretty harsh. I can tell you that in just a week, I lost my ability to walk. So 10 years is, yeah, respect, man.
No, but I got out of it, so I'm good now.
Oh, that's what counts.
Uh,
No, awesome, awesome. So we've been talking a whole lot, and the first item for conversation tonight is let's assume we could, though as we've discussed, you can't do warp travel, and that once you got there, you could actually drive around in space. You had a means of efficient propulsion. So you get there within your own lifetime rather than, your great, great, great grandkids finally arriving. So you've got there within a reasonable time. What sort of ship would actually be a reasonable choice for very long distance space travel? So not just to the moon type thing, but we're talking you're actually going out to the Milky Way and checking around there, or off to Alpha Centauri, like a serious trip kind of thing.
the thing is, time is a big problem. Have
Yeah.
you seen the movie Passenger before?
No, I have not.
Okay, it's a really good movie.
Okay, give us a very short précis of it too.
Okay, so there's about 5,000 people that moved. They're on a ship and they want to go and colonize a new planet.
Okay.
Well, not colonize it. Want to go and settle on a new planet.
Yeah.
And they're in hibernation pods.
Okay.
But suddenly the ship flies into a cluster of meteors, and one of the hibernation pods, one of the people woke up,
Okay.
and he was the only one on the ship that was awake.
Right.
Okay, and he couldn't go back to sleep. He
No.
tried to send a message back to Earth. It would take 35 years for Earth to receive the message, and then the earliest reply would be like 80 years or something,
Okay. So
because
it's
they were
clearly a
traveling near the
problem.
speed of light.
Right.
Yes. So the time when he got a message back from Earth, though, it would be probably dead.
Yes. So he's
Hmm.
basically on the ship on his own, stuffed.
Yes. And the day when he was about to go and kill himself after he was alone for more than a year, he saw a nice, pretty lady in her hibernation pod, and he went and woke her up.
Oh, well, fair enough. I mean,
Yeah,
Anything to stop you going nuts.
yeah.
But yes, you see
So he
that.
didn't tell her immediately, but sooner or later, one of the robots told her that the guy woke her up.
Okay.
Yeah, and then she was extremely angry because this guy took her life away. She was
Well,
supposed to wake
yes.
up on that new planet.
Yes.
Yeah, but later at the end of the movie, one of the crew members woke up,
Okay.
and but he also because of his hibernation part that was damaged.
Okay.
And he was very ill because his hibernation pod was actually damaged for longer than a year, the same time when the first guy woke up. So his
Right.
body wasn't functioning very well. So he also died within a few hours.
Ish.
But he also told the lady that um, there's nothing he can do about it. I mean, the guy was drowning, and a drowning man will always drag somebody down with it.
That is true.
Yeah, you'll just grab on it, on
Well,
somebody.
it raises a number of interesting points because, as we know, one of the theories, at least, is if I could basically refrigerate you, then at least you would remain as you are, even though it takes 10,000 years to get to where you're going. You'd be the same when you got there, theoretically. But yes, if there was ever a malfunction or anything, I mean, you would be SOL pretty fast. And that really is a point. So I wonder if cryogenic hibernation would really, in practice, be a viable option.
I don't think so. I think
No.
what would be a, a good option would be to get the ship and technology there and then start creating people.
That's an option. I was thinking when I went back, the only real viable option, because assumedly, if I wanted to send you all that way, I would want you to be a person with a certain set of skills and abilities to manage things on, whatever the reason was I sent you to that side, if that makes sense. So, really, the idea of a real life warp drive is the only viable option, whereby somehow I overcome the space time problem and warp you there by bending space or whatever. That's really the only viable option for interstellar travel.
Yeah, but you'll be gone forever. You're not gonna come back.
Well, if you could
You
successfully
can come back, but everybody that you left behind is gonna be gone
not
because of
necessarily.
the problem with time.
Well, that's why I say if you could successfully manage, and again, it's like you said the last time, through the idea of quantum entanglement, the superposition of atoms. If I can make it that it only takes me a couple of months to travel to Alpha Centauri and back, then it's viable because then you can come home. It's fine. You go there for a year or two and come back. That makes it a viable means of traveling through space.
Yeah,
Any other method, because of the problem of time, it becomes at best a one-way trip, but
well, you can probably
probably
come back, but everybody on Earth would be that you knew would be gone. They would have died of old age.
I suppose it depends how you solved the time issue. If you could make it that your travel there literally in real life only took a month, not just for you, but for everybody, because quantum entanglement at least implies that your superposition is instantaneous.
Yes.
So by folding space, the only actual time is your taking off and getting to the point where the space folds and you jump, and then the time spent on that side.
You shouldn't listen to Neil deGrasse Tyson.
Yeah.
He's not a scientist. He's a social media guy. He's only there for the cameras. He doesn't really know anything about bending space.
Right.
Yeah. Folding space like this, that he actually found out that he was incorrect. And I knew it way before. When I looked at his shows, it's like, that's not what they mean about warping space. And then he found out. And then he was like, he felt a little bit embarrassed.
To be fair, when it comes to quantum physics, it's a hell of a lot more complicated than most people really realize, I think. It's a lot harder to understand than anybody normally can manage, I think. I certainly don't understand a lot of it.
No, I've realized a couple of things you said, which is wrong. Like the Earth suddenly stopping. You won't fly into space. You'll maybe hit a wall, because just like you drive a car and suddenly stop, you'll get flinged forward.
Yes.
Same would happen on Earth. You'll fling forward, but you'll still be stuck on Earth. You'll still be walking afterwards. You'll stand up within a few seconds and you'll still be on Earth. The gravitational pull will still pull you down.
Only as long as we have gravity.
Yes, but if we don't have gravity, then there won't be a planet.
That is correct as well.
It's the planet that's creating the gravity.
That is also true. Well,
the mass of the planet.
It's a complicated. Yeah, no, go ahead. Greetings to Rogue, by the way, and to Jessica, who've just joined us, and Scary, who turned up. Always good to have you guys on. So let's start off, funnily enough, with a little bit of research on it. They created the USS Enterprise with a lot more thought than you might think. And in fact, the idea of that being a suitable interstellar spaceship is in fact a lot more realistic than you think. And here is why. First of all, your primary engines are away from the living area and in their own major section, which you probably would need. Secondly, your disc-shaped living area does indeed spin within itself, which means that you create within it a gravitational field so that you don't float around, which is again very, very realistic. Now, I'm not entirely certain how the wings fit in. I understand sort of that the main body below is the warp drive, whereas the wing-like structures are the when you're not going through warp speed drives to fly you around, which again would make a lot of sense. Now, within the actual living area, besides all the necessary bits for work, they, over the varying movies and what have you, they point out that they have the holodeck where you can go and actually be in specific environs that are good for your mental health, which on an interstellar mission apparently is a lot more realistic than you might think. There was a very interesting article I read. I won't go into the full details of it, but for example, Buzz Aldrin, the famous US spaceman, he went into severe depression and alcoholism when he came back. And the reason for it is that the mental stress when you are out there looking down and realizing how unbelievably tiny and insignificant we as a planet are in terms of the universe, sends such an incredible feeling of aloneness that it causes major mental issues, which is not something most of us think about when we think about interstellar travel. But apparently it's a very real thing.
Elon Musk wants to send people to Mars.
Yes.
And with our current technology, it will take 6 months to
Yes.
travel from Earth to Mars. In every 2 years, you can go take the trip.
Yes.
Because then Mars is close enough. But
Yes.
then it will still take 6 months to travel there.
Yes.
So you'll need to live on the ship for 6 months.
Correct. And not only with
And
that,
you'll probably go crazy.
you have to deal with not just the physical requirements of 6 months in a fairly confined space, but also the mental problems. And it really is apparently quite serious. So,
Yeah.
so,
Well, games can probably sort it out.
well, to a certain degree, I think that might be a requirement. Especially VR type ones where you can literally go walk in your garden, even if you're not really there. Now, in terms of, there are a number of things that make sense about the USS Enterprise. The ship is actually designed in a believable and reasonable way according to good science. And in fact, apparently Gene Roddenberry did his homework and he insisted on it, which makes it even more interesting in that regard as well. So he said, and this is a quote, "We're out in deep space on the equivalent of a cruiser-sized spaceship. We don't know what the mode of power is, but there will be no trails of fire, no streaks of smoke, no jet intakes, rocket exhaust, or anything like that. It's a deep space exploration vehicle operating through the galaxy, and as there is no atmosphere in space, you wouldn't get any of that. Absolute fact." So when they designed the ship, they did it according to real science and the real living conditions you would have to be in long-term in space, which is absolutely fascinating. And it covers a number of things, like you said. If you want to go on a trip with the old Muskmobile to Mars, you're looking at the moment at least, 6 months in space. Now, not all that long ago, we had the awesome joy of the COVID lockdown, and we were stuck in our houses. And I mean, come on, that wasn't that long, really, but
Yeah,
it was
but people committed
rough.
suicide, probably.
Yes. So even short term, it's really hard on you. Can you imagine 6 whole months? Now, an interesting fact is my fiance's daughters go and work on the cruise ships. And they are on board the ship for 3 months at a time. In those 3 months, they do make landfall at varying ports. They are not off planet, but
But they're probably surrounded by thousands of people.
well, not even with that, it is a requirement for health that in between trips out, you have to spend at least 2 months off the ship, because the confinement gets to you regardless of. And that's nothing like the kind of confinement you would be on 6 months knowing that you are not even on the planet. Yeah, I could see serious mental problems if it wasn't dealt with very carefully.
Hope they get a nice crew, because there's not going to be a lot of people on a ship.
Well, the really big liners, I mean, you're talking 3,000 or 4,000.
Those ships are actually tiny. They look really big, but to actually put living space in it for people to live in, it's tiny.
Well, kind of yes, kind of no. They do vary in sizes. The one girl went on what we would call a small cruise liner, and I think there was only about
I thought you were talking about Elon Musk's Starship.
Well,
Not the,
this is where I'm comparing, because the small cruise liners still we're talking quite a lot of people. Now, that means at the very least that if I don't get along with you, there's plenty of other people to talk to, kind of thing. Now, how many people can go onto one of Musk's ships? I mean, when what? Call it. Let's be generous and call it 100. Okay. If you've ever been in boarding school, you know very quickly that if you have a fallout with somebody, it's quite a serious problem. You end up with people taking sides, you got all kinds of arguments, and if you know you cannot get off the ship, how much worse will it be?
so you were actually right with your prediction. So it is up to 100 people
No, yeah. There we go.
on the ship.
That's very, very few for a confined space. If you have a fight with somebody, it will be a serious problem.
Yeah.
6 whole months, and there's no docking at a port or anything like that. It's you're stuck, staring out at the earth getting further and further and further away.
And as soon as you land, it's not going to really be any better.
Nope.
Then
Immediately,
you're going to
it's
start working, and you're going to have to work hard.
and with the people you've had the falling out with.
Yeah.
Yeah, I could really see that being quite a serious challenge. I mean, they're going to have to pick so carefully. And I mean, if people start up...
Once you're on the planet, there's also no other place to go. You have to stay with your crew.
And if you're
You
going
can't
to...
just go take a walk.
No, you can't. And if you're going to start up relationships, what happens if you and I both fancy the same chick and start a fight over it? Now what?
Or you actually made a chick, and then you broke up. And
Or
she's
worse.
going to stay next to you all the fucking time.
Right? You know, the fact that you can't stand my face, you've still got another year or two where I'm right there in your face and there's nothing you can do about it.
Yeah.
Yeah, I can see issues with that quite seriously. They're going to have to be real careful.
And people are bastards. They want to piss each other off.
Right? People are. It's a reality, one way or another. There's not much you can argue with that. Yeah, I think there would be issues. Also, at the end of the day, and here's the big point, and they did raise this in Star Trek as well, which is very interesting. Rogue came back. Hey, Rogue. Um, they don't build the ship on land. It's built in space because of its size. And then you will travel from Earth to where this sort of space station where it's been built, and it flies out from the station. That really is realistic as well. The kind of size you would need for interstellar travel, you couldn't build it on Earth.
Yeah.
Not practical at all.
That ship in Passenger. So it had 5,000 passengers and like 3,000 crew members. So a lot of crew members as well.
Yes. Now, you see, that's actually more realistic. You need the numbers.
Yeah. And they had everything on the ship. The ship was massive and they had spare parts for everything, apparently. Not just that, they had animals.
Okay.
They had plants, trees.
That would make a very big difference, I think.
Yeah. It was also a rotating ship, so it had artificial gravity.
Yes. So even before we're traveling between the stars, the ship itself will have to overcome a number of issues. You would need the gravity. Apparently, you can get quite severely brittle bones if you're in.
Yes.
Yes. So there again, the health issues.
Just your bones, your muscles, everything will start.
Yeah, that would be bad. So, I mean, right off bat, you're dealing with an incredible number of challenges even before you started going.
And you'll actually forget how to walk.
Yeah. Well, like I said, I was in bed for a week, unconscious, and then another 2 weeks conscious, and I couldn't walk anymore. I had to teach, I just had no strength in my legs. I had to teach myself again. And that's like a minimal time, and I struggled. So can you imagine 6 months? Which is the
Yeah.
other, yeah, that's the other reason why I think cryogenic freezing isn't the option that we think it might be. I mean, you'd get out the other side and you'd just fall right over. Your bones would snap. You'd be so weak. Eh.
Well, there's going to be a room for exercises on
Yes,
the starship where people are going to run and stuff like that. They're going to strap themselves onto a, what do you call that machine? Then run on it.
yes, absolutely. But if you had internal gravity, it would solve huge numbers of problems.
Yes.
I mean, right
But
away.
starship wasn't designed for that.
So we will have to figure a way to handle the mental issues, figure a way to make sure you got gravity. Food and stuff for a journey that long would clearly be a challenge. You would need
Well, it
an
seems like
internal
they've sorted
production.
out the food. I'm not sure how, but yes, there needs to be the ship. New cargo needs to come in every 2 years. So
Yeah,
it seems like they will have enough food to survive for at least every time a new cargo ship comes in.
true. But you would want very much in case of issues to have some way of growing or producing food.
Yeah, which will take quite a while because you still need to build a lot of infrastructure on
Exactly.
Mars.
Well, one of the
On the
things
ship,
that
it's a bit impossible to grow food.
one of the things they were saying is if AI goes far enough, if I could send robots ahead who would do the main building, that would solve a lot of problems. And I think they are quite correct in that regard. So that when you arrived, the majorities of the structures would be in place.
Yeah.
That would make a very big difference. Because otherwise, can you imagine you get there and you're told, like, you see that patch of ground? Get going. I mean, right off, that would be harsh.
Yeah. No, humans, even people on Earth, you can't go and build the farmland with your hands.
Right? I
They have
mean,
to use big machinery.
exactly. So there's a lot of things that are an issue. Hey, Oreo joined us. Hey, Oreo. So yes, right off bat, there's a number of things, but according to a number of scientists, the ideas, at least, behind the Starship Enterprise are what you are needing to think about. That would be the right way to go, which makes sense to me. The designs, the way you've got separate engines to allow for different kinds of propulsions, absolutely, that makes total sense. So it's not the same engine that drives you through warp drive as once you get there. Your issues will include, of course, your fuel source, which we spoke about in the last one. You need something which is going to last you a very long time. But the kind of things that would work like that generally are dangerous. So using nuclear power would give you the power, but you need a hell of a lot of shielding.
On the movie Passenger, they used a fusion reactor.
Well, yes, that's basically nuclear.
Yes.
Now, you mentioned in the last live, and I went and did a checkup on it, the idea of an ion drive, and you are quite correct in that regard. The ion drive seems like the best choice because it is non-nuclear, but it lasts as long as nuclear fusion would. Actually making one is a major challenge, but if you could, it has a number of advantages over nuclear power because an ion drive creates its own push. And of course, in the vacuum of space, that's one of the reasons why normal fuels don't work. There's no atmosphere to push against.
Yes.
But an ion drive might be able to overcome that because it creates its own push. So it's not doable yet, to be fair, but it absolutely has options. Okay.
Just an engineering problem.
Well, yes. If you can get around a number of the difficulties, there are options. So what you want are two sets of engines, exactly as on the Enterprise. You've got your main core engine, which is away from the living area, which is the engine that gives you your warp drive for going through space. Okay, however that might work. Okay, and then you've got your ion drives, which allow you, once you've got that size and you don't need the amount of power that you need to warp, to maneuver you around there over the shorter distances, if that makes sense. So yeah, the Enterprise is correctly made. having the Sorcerer part separate to the engines is an absolute health and safety win, to keep you away from the more dangerous aspects of these massive drives.
Nobody's talking about stopping. Like, everybody's talking about how to travel
Well,
vast amounts of speed, but how do you stop?
that's the other interesting thing of the ion drive. Because what you would do with the correct use of computers to manage the calculations, your drives actually go both forwards and backwards. And because an ion drive creates its own push, you can use it as brakes as well as propulsion.
So you just flip the ship around, or maybe have another one in front to
Well,
stop.
if you look at the Enterprise, you've got those two tubes on either side, right? Your drive can either drive to the back and push you forward, or to the front and push you back. So having one on either side is what allows you to turn. So it overcomes a number of those problems. Say again?
You can't just. You also need to stop slowly. You can't just suddenly stop.
Correct, and that's why the ion drive is the best choice for that kind of thing. You modulate your drive so that you come to a halt, you don't just stop dead.
Yeah.
Now, how that would work for the sort of drive you would need to do the actual jump through space, the warp, that I'm not sure, and that's another whole engineering nightmare.
I wonder when AI would be capable of solving our engineering problems.
Well, that's the other possibility. So maybe, now you still have to overcome the whole time issue though. And the only real plausible answer that might be doable, we both agreed on in the last live, was quantum entanglement. That's about the right way. Without that kind of thing, the time issue is just not overcomable. So there's that. However, is it possible to travel through a black hole? Apparently, what I said the last time was not quite correct. It's worse.
Yeah, you'll turn into spaghetti.
Yes, so the spaghettification, not just an atom flat, but literally an atom thin and massively, massively long. So yeah, that's a problem. Also, here's the thing. Once you go in, you get to what they call the event horizon, which is the point of no return. You're going through whether you like it or not. And the escaped velocity to break the event horizon is many times faster than the speed of light, and we can't exceed the speed of light. So once in, you better be committed, even if you could survive. So that's another problem. So that, combined with the fact that the gravity of a black hole is so immense that, yes, you are spaghettied, and even a super dense star would be spaghettied. So yeah, we don't have a chance at all. Now, here's the other thing. They say, and I don't know how they know, because to me this is, really? Stupid TikTok. To me this is something that I find a bit of a weird comment to make. Because as far as I know, we don't know. And I couldn't find any confirmation that that shows anybody does know, if that makes sense. Black holes are not tunnels or portals to other universes or dimensions. Traveling through them is just a science fiction trope, but isn't scientific. Now, there's
I guess
plenty.
what a black hole is just a enormous amount of mass.
Well, that's one
So
option.
you're not gonna go anywhere. You're just gonna become part of this big mass. It's just a big star, but everything is just so compressed.
Well,
You can't really see what's going on there because light doesn't travel back from it. Light stays there.
that's one theory, but
Everything just falls flat
I, I, I,
into.
I put it to you. The problem is it's a theory because we don't actually know. The other theory is that a white hole is the opposite end of a black hole, and that in many ways universes are created where a black hole's collapsed in on itself and spewed out the other end, and that they occur so that the universe remains a dynamic thing. Now, we don't actually know. So when they say, according to science, well, no, according to certain theories that some people have in science, because nobody's gone into and survived a black hole, we don't know where it goes.
It's probably not possible
So,
to
yeah,
ever come back. So maybe you can go through it and reach the other side,
it's
but you're not going to
possible.
come back and tell us.
Well, that's the issue. So you've got multiple problems with even the understanding for a lot of reasons because we really don't know. There is no way of knowing unless you could go through one here to come out there, find the correct one there to come back here. Eh,
So
you
where
know.
is our white holes?
Well,
Why is it called a hole?
therein lies the problem because again,
Wouldn't we also have white holes?
okay, here's the problem that we are starting with. When we talk about the universe, we're actually using very bad technical language. Mostly because 99% of us are not scientists and we don't really know what a universe is. We kind of do, but we don't because of the immensity of size. So there is only one universe in which everything is. However, the universe is divided up into galaxies. And there's quite a few galaxies, okay? Now, galaxies contain multiple stars, all kinds of things. Our galaxy, as I understand it, and I've been using it wrong already in this live, we're actually part of the Milky Way. You just can't see it like that. We're in the same galaxy. Now, given how far the Milky Way that we see in the sky is from us, it gives you an idea of how big a galaxy is. Now, within the galaxies
Did
are
you think we
multiple...
were not part of it before you suddenly realized that we are?
Well, I hadn't
We
thought of it in those
we are like
terms.
in the middle. Well, not right in the middle, but we are
Correct.
in the middle from the center to the end.
Yes, so the galaxies are so immense that we can't even get to the other parts of our galaxy.
Well, our
With
galaxy is really big, and it takes about 100,000 years for light to travel from one point, from the one side of the galaxy to the other side of the galaxy.
correct. Now, our galaxy is pretty small in terms of galaxies,
Yeah,
which gives you an idea of how much distance we're trying to fathom here. You know,
we're one out of a 2 trillion galaxies, and I'm not sure. People don't really know how big is a trillion.
No, I actually had a discussion with somebody the other day in terms of money. And if you think about it, this is unbelievably correct. And it's a mental exercise you can try. If I say to you, here is 20 Rand, you are able to mentally encompass the value of 20 Rand because in your head you know it's like a loaf of bread. So the
Yeah.
idea of the value of 20 Rand you can imagine. Okay. Now, if I said to you 200,000 Rand, you can encompass that as well. It's sort of a car. Not the best car, but a car. Right? So you can encompass the concept of 200,000 Rand. Now, by the time I start talking to you about 1,000,000 Rand, you're on shaky ground. Okay? You're starting
Well,
to get...
a million can't even buy a house.
Nowadays, yes, but you can see how you're starting to reach the limits of value to thing in a
Well,
way.
one of the ways to see numbers is by counting them by seconds.
Right. But now the point that I'm getting to is when I say to you 1,000,000,000 Rand, you're on very shaky ground in terms of value to thing. Now, when we translate that same concept to distance, the distance from here to the moon, we kind of can figure. And that's really, really close. When you start talking about the amount of distance just to get to the other side of our galaxy, we're shit out of luck. It's just too far for us to really comprehend properly. And when you start talking about going into the rest of the universe, it's not even theory. And there's our problem. I mean, we're a race that cannot get to the bottom of our own ocean. Our concept of how far away Alpha Centauri is non-existent. We don't really have a complex understanding. It's just too much for us. And that's the problem.
Okay, so I did the calculation quickly for a million to count to a million.
Yes.
In if you can count 1 second per number,
Right.
it would take you 11 days.
That's
But
pretty
if you
harsh.
count, but if you count to a billion, it would take you 31 years.
Okay, there you go. And that exactly illustrates the problem we have comprehending
From 11
distance.
days to 31
31
years.
years. Right there, you see the problem we have. The enormity is just like, my God.
And I can
So,
imagine if it's a trillion, then it's going to be, oh,
3
I
times
don't know.
that is 100 years, basically.
No, you
Well,
see, you got it incorrect
oh
so
no,
badly.
it's geometrical, isn't it? It's not arithmetic.
I'll try it quickly. So it's 1 trillion divided by 60, so we get minutes divided by 60 again. We get hours divided by 24, so we can get days divided by
65.
366, and we get 31,000 years.
Okay, there we go. So it's clearly an issue.
You can't count to a trillion.
No, you cannot count to 1,000,000,000,000.
Uh,
Okay, so yeah, I think that illustrates very well the difficulties with how far we're actually talking about trying to travel. Your brain will melt. However, on that happy note, wormholes. So what is a wormhole? Now, first of all, wormholes are hypothetical. we don't actually know if they exist. So a wormhole is better than a black hole because a black hole has the problem of gravity. But if we could get into a wormhole, that would be different. And now this is the quantum entanglement issue. So a wormhole will connect disparate points in space-time, the very issue that we have a problem with. So instead of having to travel between point A and point B, going through all of the space between those two, you drop through a wormhole where point A and point B are immediately adjacent. So it's essentially a kind of tunnel thing where 2 points in the space-time continuum are in fact connected. Now, wormholes are based on the special solution of the Einstein field equations. They're consistent with the general theory of relativity, but we don't know if they really exist. They might just be a projection of a four-spatial dimension, analogous as to how two-dimensional being could experience only part of a 3D object. Now, we are 3D beings trying to understand a 4D object, which is infinitely more confusing. Just so you... So have we confused ourselves yet? I think so. Nevertheless, essentially the idea is that there might be many wormholes in the universe if cosmic strings with negative mass were generated in the early universe. Some, however, suggest that you might be able to create them artificially. If you could, you are therefore using the collapse wave theory of quantum entanglement, creating a situation where the there and the here are immediately adjacent, which means instead of having to take the time to travel between there and here, and having to pass through the space between there and here, and having to deal with space debris between there and here, and fuel, and food, and oxygen, which we hadn't even touched on, and all the other issues, you have an immediate jump from there to here, solving all of the major problems, if they exist. So you're creating in four-dimensional space the equivalent of a one-dimensional tube that allows you to elide and superposition places through quantum entanglement. Now, I said all of that based on my research notes, and I want to assure you that I understood none of it. If you knew what I just said, please let me know, because I didn't. Did it make sense to you?
Wormholes are strange. We haven't found any evidence of wormholes before, and we can't create them. It is still theoretical at the moment, but I think it's an Einstein's theory, right?
It's part of a solution to certain aspects of the Einstein special theory. Now, the theory comes...
The wormhole can't travel back in time?
Well, no. What it does is it bypasses time. And it does so because through the idea of a superpositioned molecule, or in our case, a very large clump of superpositioned molecules, you're jumping via one-dimensional space from here to there. So for a brief moment, here and there become the same place, and you sort of squink across that side, and then it becomes four-dimensional again. And because it's instantaneous, you've bypassed time, which is our biggest problem.
Yeah, no, time is so weird.
Right? So, yeah, that in theory would solve at least the warp drive problem. Now, they say that theoretically you can create wormholes and that they exist mostly, and here's the interesting thing, there's a stream of thought that says that this is how electrons move. And that's how you get ionization.
So they think wormholes is just, again, another engineering problem that we need to solve?
Well, yes, because ultimately an ion drive works on the quantum theory of entanglement using using the superposition of electrons to create a electromagnetic field, kind of like a radio wave, but much higher frequency. Okay. So you're creating your own specific environment, which can be used to propel something, but theoretically is in itself a means to create a wormhole. Now, if you could create the wormhole big enough to take your entire spaceship, you then do what electrons do and jump between two locations through superposition of quantum entanglement, whereby there and here are forced to be the same place. Now, it sounds good, except how do I ensure that the there that I want to get to is the there I'm creating? And most importantly, can I recreate the place, the GPS, if you will, of here, so that when I'm ready, I can come back to here and not suddenly find myself, I don't know, 10 billion light years. Right. So there are challenges that we don't have answers to right off bat. Not going to lie. But
it would be so scary if you jump and then you find out now you're right in front of a black hole and there's no way to get away from it.
Well,
you're gonna get stuck in it.
Or what happens if you jump and you reappear in the middle of a sun?
You'll become the sun. You'll become part of it. You'll blow up into atoms.
Absolutely. So let's just say that while if these theories are correct, it's the most logical scientific way forward to do interstellar travel, it is not without its major problems. Let's just say that. Would I trust it? Yeah. I'm kind of dubious. So, yeah, there are problems even with the most likely idea of what they would now refer to as a Schwarzschild's wormhole, which is the first kind of wormhole solutions that were discovered, which would exist within the Schwarzschild metric, which kind of is similar to an external black hole. The problem is that it collapses too fast. Now, wormholes that you could use to transfer in both directions, transversible wormholes, would thought to be possible only if exotic matter with negative energy could be used to stabilize them. I don't know what exotic matter is, unless it dances on the weekend in the clubs. And negative energy density sounds like the kind of thing that somebody made up because they didn't have a good explanation for what they're talking about and needed a pretty cool answer. So right away, we're going into realms of, I don't even know what that is, and I did the research.
They've never seen it because they can't find it. It's like it's dark matter and dark
Yes,
energy.
exactly. Everybody talks about the discovery of dark matter, but the whole point of dark matter is you can't see it.
Yeah.
So how do you know it's there if you can't tell if
They
it's
claim they
there?
can see it because they can see its effect on gravity, on other stars and stuff like that. So they can see that a galaxy gets formed so quickly, but there's not enough mass in the galaxy visible to see like why the galaxy would form so quickly. So there had to be more mass there, which you can't see.
Right. Exactly. So basically, we've posited a something that we don't know what it is or how it works or what it does, but it's doing something, so we think it must exist because otherwise we don't have an explanation.
Yeah.
Yes. So, yes. I did find more research on this, and it got even more complicated. And if you think dark matter is hard, negative mass cosmic strings are even more complicated, and I'm not even going to try. We are going to move on to the next topic, simply because, my God. So, in short, you've got to use quantum mechanics. Now, according to what we are told, quantum mechanics is essential for understanding matter and energy at the atomic and subatomic levels. I don't. Atomic structure and chemistry involves understanding the behavior of electrons in atoms.
All right, just give me 1 minute.
No probs. Chemical bonding and molecular structures, all of which are governed by the laws of quantum mechanics. The problem is quantum mechanics is in itself a theory. We don't really know if it's right. Nuclear structure and forces allows the use of nuclear energy, which is governed again by this theoretical quantum mechanics. Quantum theory, they say, helps explain the mechanisms behind the process, like the glowing of hot objects, black-body radiation, how the sun shines, nuclear fusion via quantum tunneling, and potentially photosynthesis in plants. All of this, and this is now me quoting me, is beyond me, because their explanations are basically saying it's a theory described to manage to explain a theory of things that might be correct, but we're not sure, and 90% of us are not clever enough to figure it out. Yeah, I said it. But it is the flavor of the moment, and therefore they use it to explain and describe semiconductors, transistors, computers, smartphones, smart devices, and all of that kind of stuff using the quantum mechanical wave nature of electrons. Lasers and LEDs used in all kinds of things are a direct application of Einstein's quantum theory of radiation. Medical imaging like MRIs uses the quantum property of spin in atomic nuclei to produce images, they think, and precise timekeeping works via atomic clocks using integral global positioning systems and the precise energy transitions of electrons in atoms. Ultimately, What I'm telling you, and it might not be correct because I'm not sure I understand, quantum mechanics deals with electrons. Electrons make everything we know that exists possible to exist, and without it, we're a bit shit out of luck in understanding anything. So we created a theory about the theories we have, which might be right, in an effort to understand it all. This means then in the future, we might be able to create things like quantum computers, which would be exponentially faster and have far greater memory than anything we've got now. Secure communication using cryptography through entangled particles so that you literally cannot break the code because the code isn't in existence until it is. Thank you, Schrodinger's cat. Advanced sensing and meteorology, where you're literally using the superpositioning of electrons to predict and explain what may be going on inside something or in the progression of the weather, etc. What does any of that mean? I don't even know what I said. But there you go. That's what we're talking about. Do I understand it? Not even slightly. Now, to make things even more complicated, using the really badly yes, do go on.
No, give me one word. What you were talking about. What you don't understand.
What quantum physics actually is at base. I know it's about the superpositioning of electrons and how they move in relation to everything and make what is possible to actually be.
I'm also not completely sure. It's smaller than atom. It's quarks and
yes, it's the actual building blocks of which atoms are made. So quasars, quarks, and all of that. Now, to confuse you further, this theory that we do not understand, that is a theory created to explain theories created to possibly explain some of the things in the universe, we then have quantum entanglement, wherein the quantum state of a particle in a group cannot be described independently of the state of the others, even when the particles are separated by large distances, which means that the manipulation of the particles in a specific place directly relates to and will have effect on the particles in a different place, no matter how far away they are. You got all that? So, the measurement of the physical properties of position, momentum, spin, and polarization on entangled particles can be found to be perfectly correlated, which means that if I could get the spin of a whole spaceship and its contents and people on board and figure a way to synchronize it with particles in Alpha Centauri, in the galaxy there, and spin them in such a way to create a superpositioning, I can take that which is there and you which is here and swap them, thus overcoming the space-time continuum and immediately traveling interstellar.
Yeah, with no time in between.
Correct. Can it be done? Electrons do it all the time. How hard can it be?
Yeah.
Yeah.
The people who come up with these theories are the same people that also say that nothing really exists until measured.
Correct.
And only while measuring.
And therein is the collapsible wave theory as opposed to the existent particle theory, which is happening at the same time until measured. Schrodinger's cat.
Yeah. Strange, very strange.
Yes. So if you understood none of that, you're normal like all the rest of us. If you understood all of that, please call NASA. They want to talk to you. So, how does this actually affect us? Well, they are now using the entire quantum theory thing and applying it to pretty much everything, not just science. So, philosophy, psychology, sociology, all of it is being used in this way. So now we get to be completely confused and not understand everything because of quantum. So, next topic before our brains melt out our ears. Is a Star Trek transporter possible? If so or if not, why? And what are the issues? So, number one, no, it's not possible now with our current understanding of physics. It is thought it may never be. However, with enough quantum entanglement and AI to do the thinking for us, that might not be the case. Maybe. However, let's go further. Because wait, there's more, and also just $49.95. So, the challenges are in scanning, storing, and reassembling a human at the quantum level. Quantum teleportation of information between particles is a real process, but it's not the same as moving physical objects or people, which would require knowing the exact quantum state of every single particle in your entire body, including what you had for lunch. A task that is fundamentally impossible due to the Heisenberg uncertainty principle. Now, for those of you who don't know what the Heisenberg uncertainty principle is, I will tell you. Before we move on the next bit of, oh my God, this sounds awful. So, the Heisenberg uncertainty principle states that it is impossible to simultaneously know both the precise position and momentum.
I just read something.
Yes.
Quantum teleportation
is real.
A real-world process called quantum teleportation has been demonstrated in the laboratories.
Yes, it's real. On a single particle.
The Star Trek concept.
Yes.
According to the Star Trek concept, it is not possible to build a Star Trek-style transporter with current technology, and many scientists believe it may never be possible.
Correct.
The transporter relies on dismantling and reassembling a person at a subatomic level.
Yes.
A process that is far beyond our scientific understanding and faces immense practical and philosophical challenges.
Correct. Because for a single particle to be mapped, we can figure out the position and speed of it, and it can jump. You are made up of so many particles, all of them different, with their own individual position and speed. It's so intensely complicated that just mapping you would take so long.
But the physics is there because apparently quantum teleportation has been achieved.
Yes, it has.
But only teleporting quantum matter.
Yes.
But you can't teleport a person.
No, we would need the kind of storage space to map you that was so huge. It's the equivalent of comparing the best modern computer in the world today to the very first one created by Charles Babbage. Only what our very best one in the world today is Charles Babbage's first computer. We need to be that far forward as that comparison, if that makes sense.
Well, would take an immense amount of energy as well, according to
As well.
Einstein.
Yes, that is correct. Huge thanks to Elzito for the likes there. I do appreciate. Like, share, subscribe, guys, and do comment, please. It's not just a two-person convo here. Throw in your thoughts. But yes.
Which is strange because I'm not sure how it works. It's engineering problems, but
Well, it's
you
more
need
than engineering in
energy
this
to
case.
to
Because,
change the human body in from mass into energy to then transport it, which I don't know.
okay, so starting, as I'm saying, with the Heisenberg uncertainty principle, is that the more accurately you measure one property, the less accurately you can measure the other. So the fundamental principle of quantum mechanics, which has a long and complicated formula, is that you learn more about either the position or the momentum, but the accuracy of the position is the uncertainty in the momentum. Now, this was created back by Werner Heisenberg in 1927, and it's a cornerstone of quantum physics. Now, it's rooted in the fact you have the wave-particle duality of matter, meaning that you're trying to use something like a wave by understanding it as a particle, which is fundamentally not possible. The implication is that while particles can do it, trying to make it happen for the entirety of you is just...
Have you ever heard of the slit experiment before?
Yes. Which you force a particle to work as a wave, but if you look at it as a particle, it crashes.
It's a wave. They use the wave to work as a particle, so they measure the wave and see where it lands.
Yes.
And it's also unpredictable.
Because of the Heisenberg uncertainty principle, the harder you see, it's the exact opposite of Schrodinger's cat, where when you look at Schrodinger's cat, it becomes what you are looking at it as because of the way it works. This works in exactly the opposite way. When you look at it, it stops working like that.
Yeah.
So, but both of these principles are working at the same time. So, the short answer is, as per current science, current fueling of things in science, and all of that stuff, no. And that's even before we've got to the important bit that when I reassemble you on the other side, I need to reassemble you as you and not as a squinch.
Yeah.
You're not just the sum of your composite material. It's a lot more complicated than that. So,
You'll probably assemble the person as
a
you
puddle.
measured him, which would be a bunch of numbers, and
You'd be a puddle.
Yeah.
You'd be correct, but a puddle. So Yeah. Now, the theory's great, but then again, if you can use quantum entanglement to superposition an entire spaceship, doing
Like
it
you said,
just to you,
measuring a person. I mean, you have to measure everything instantaneously because
yes,
everything in your body moves. You can't just measure particle by particle and then put by particle back together again. You'll
correct.
have to measure instantaneously and reassembly instantaneously.
Instantaneously, yes. Now, interestingly enough, if you watched the early Star Trek movies, this was a problem. And on occasion, when people were reassembled, they were not reassembled correctly, and it was an issue. So even within the Star Trek movies, they admitted it was seriously a problem. And we haven't even got into how it might affect you mentally to be transported. I mean, yeah. How do you map the physicality of your brainwaves?
Yeah. No, you might lose consciousness and might get it back.
Well, I would have to not only measure the brain, I would have to measure the current activity within your brain
But that
and
activity
all of
still needs
your,
to be running when you get there. Otherwise, somebody
yes.
needs to come and shock you back to life
And
again.
what about your memories?
Well, your memory is just hard, it's coded into your brain.
Is it?
So that could still be there.
Is it? We think
Yeah.
that it is. We
No,
th-
that's how it works.
no,
It gets
it's a
coded
theory.
into your brain
It's a theory.
through electrons. Then it just sits there and it can disappear after a while.
But it's down to electrons. So if you don't reassemble the person with that electron in that exact position, moving in that exact direction at that exact speed, your memory's fucked.
Yeah. Yeah,
Yeah.
no, there's lots of
Yes.
problems with this.
It's an issue. It's a
System.
problem. However, it's an interesting problem.
But I
Nevertheless,
can guess if you reassemble the person completely, he will probably be dead and you have to restart his body.
that is yet another issue. You are quite correct. Assuming I got you there correctly.
Yeah.
Now,
No, you would obviously lose consciousness for a while until you get
yeah, I would say it would probably have a severe effect on you.
yeah.
But what about then, if we can't have a transporter, can I have a phaser? Well, no. It relies on fictional physics and particle technology that doesn't exist. Now, lasers do exist, but a phaser, with its ability to adjust its intensity between stunning, killing, or disintegrating targets using a handheld device, no, because we don't have actual particles that work in the way they do in the fictional phaser. Okay, so Nadian particles in Star Trek aren't even a theory in the real world. The idea of a power source that could disintegrate or vaporize targets would require way more energy than we could ever put in a portable handheld device. Also, if it was that powerful to create that much damage, the amount of heat it would generate while creating the phaser beam would be so high that your firing it would self-destruct it and probably you. So phasers are out. But what about lasers? Well, we have lasers. We know this. We've got laser beams. They do exist. And yes, they are being developed as weapons, but they are bulky, they require very large power sources, and are not capable of the varied settings of a phaser. What about particle beam weapons? Well, the US military has been developing particle beam weapons, but they're not handheld and are very large scale, designed for specific tasks. What about stun guns? Now, our stun guns use electrical currents to stun a person by disrupting the nervous system, but they're not energy beam based weapons. However, interestingly, they have developed a sonic version of a stun gun that basically disrupts your inner ear balance, rendering you confused, nauseous, and unbalanced. And it does work. So we don't have real lasers yet. We don't and cannot have phasers, but we've kind of got the next best thing. So laser weapons, no. We don't have the ability to create that much power in a handheld device. And there are too many material things in the air that would disperse the beam before it hits you, rendering it by and large not greatly effective in terms of pew-pew 2 shots like that. Even modern lasers that we use to cut things do so fairly slowly, and they're on a very small scale. Is it possible? Yes. Do you think we will ever get them? Probably, but not yet. So you can have your laser guns, but if I can have laser guns, what about something better? An ion laser gun. So an electrolaser ionizes the target path and then sends an electric current down the conducting track of ionized plasma, something like the way lightning works. It functions as a giant high-energy, long-distance version of the taser, without needing wires between you and the target. So it is possible, but way too bulky at the moment. Pulsed energy projectile weapons, however, emit an infrared laser pulse that creates a rapidly expanding plasma at the target. The resulting sound shock and electromagnetic waves stun the target, causing pain and temporary paralysis. The weapon is under development and is intended as a non-lethal weapon in crowd control. But if
that fire in California that happened recently.
Yes.
Okay, so some people think it was they used a military type of weapon.
Yes.
It was from outer space to burn the place down.
Well, here is why they think so. Because this
melted down. I mean, normal fires can't really do that.
Correct. This is exactly what we are talking about right now. Pulsed energy projectiles. Now, we do not have the power source to make it possible in a laser gun type thing. However, to do it from a satellite with a very, very large power system powered off solar energy, that's a different story. A focused pulsed energy beam is possible. And that means that those fires in California might have been from one of these in testing.
Yeah, I know you can
Not,
buy lasers now that can basically cut through things.
yes, yes, you can. They run out of battery bloody fast. I can tell you that for nothing. Because they use a huge amount of energy, but they are possible. If we could develop a more efficient power source, that would absolutely be doable.
I've never played with them, but I just saw them on YouTube.
Correct. So, in theory, at least, all of this is possible. Practical? Well, if the military's got a better version they ain't telling, obviously.
Yeah, no, they've got lots of technology which they're not going to share because it's weapons
Correct.
technology.
Exactly. But for you and me, no. Now, then there is the Dazzler, a directed energy weapon intended to temporarily blind and disorient the target. Again, this is for crowd control, catching criminals, and all the rest. It emits an infrared or invisible light against various electronic sensors and a visible light against humans. So they're intended at least to cause no long-term damage to the eyes. So they're kind of like a laser gun with a certain amount of electromagnetic pulse in it. They will disorient you, blind you, cause you to fall over. They are technically non-lethal. How much power can you put in it? But the idea is you've literally got a kind of phaser. Set to stun, take you down. They work not only against people, but against electronics as well. We know that the Chinese have an anti-drone version. The Soviet laser pistol was a prototype they wanted to make for cosmonauts, and the Navy has a very, very big one they are field testing currently, called an optical dazzling interdictor for the Navy, or if you want, Odin. And it's supposed to be able to do exactly that. Does it? Well, I suppose we'll find out. We have a number of different things. The US has Project Excalibur. The Soviets have a laser weapon. And they have the 1K17 Zati. And the Polyus Skifdiem, whatever the hell that is. They are creating an anti-satellite version called the Terra 3. We know that the US have the Army Missile Command laser, which can take out missiles or possibly send them back. There's a whole ton. And they are personally pretty impressive. And if they work, they will change the shape of warfare. Let's just say that. Vatos Locos wants to join. Sorry, buddy, I do not know you, so I cannot accept. But nevertheless, let's jump to the next problem, food replicators. Now, we do know that...
I want to test something. I'm not sure if you'll allow me to do it. I want to bring someone into the conversation.
If you can, do. If not, let me know and I'll see if I can. Tell them to share the live with them and I will add them when you tell me who they are.
No, they're right here with me.
Okay.
Okay, so we are having a discussion about a food replicator.
Yes.
That sounds like a fascinating idea. A food replicator, you say? What kind of food do you envision it making?
Well, we want to know if it's possible to make a food replicator.
That's a great question. In theory, it might be possible to create a device that could assemble food from ingredients, kind of like a 3D printer for food. What features would you want in a food replicator? What kind of meals are we talking about?
Well, I think the questions that you're asking us are boring questions. We actually want to get to the scientific parts of our conversation.
Understood. Let's dive into the scientific aspects. What specific scientific concepts are you interested in regarding a food replicator? For instance, are you interested in the molecular processes involved or the energy requirements?
Both.
Both.
Excellent. Let's start with the molecular processes. Imagine a future technology that could manipulate molecules directly, arranging them to form various food structures. This could involve advanced forms of chemical synthesis or even biological mechanisms. What kind of precision do you think would be required for this?
I was hoping you'll answer all the questions.
Fair enough. In a hypothetical food replicator,
Hey,
the
Lily.
precision required
Thanks for
would
the
be
likes.
extremely high. We're talking about manipulating molecules at the atomic level to create the desired textures, flavors, and nutritional content. This would likely require technologies far beyond what we have today. Does that align with what you were thinking?
Okay, so I'm just gonna put that on pause. I'm not sure if it helped at all.
Well, here's the thing. It doesn't. The first issue is that if you wanted a food replicator, something like in the science fiction, I can go up, press button and go, I want a cheeseburger, and it goes, and a cheeseburger appears, okay? Essentially, the process is you're taking raw materials or matter, breaking it down, and reconfiguring it according to the map of the requested food. So, number one, I need to be able to do exactly as with a transporter and map the food so that I know exactly how to put a cheeseburger together from particles. That's the first problem. Second problem is knowing what kind of base materials I could start with. If I'm doing it from scratch, ultimately, all I need is something I can turn into protons, neutrons, and electrons separate, and then reassemble to create the required elements in the correct way, if that makes sense. So it would be advantageous if slightly gross, because any waste, it wouldn't be waste once it's been broken down, because it would simply be separate protons, neutrons, and electrons, and I would then be able to put it together in whatever form I want. So it would be a massive saving in that I would have materials from waste. Hey, Jay.
Hello.
How are you doing?
Well, that's what I was gonna say. It's,
I do live stream. My microphone not working.
Well, I'm sorry to hear that.
recycling would be so much easier then.
Yes.
It's almost 12 o'clock and you don't have 1,000 likes.
Unfortunately, that is how it is. It's been quiet tonight.
Where's Endless Thoughts? Where's more?
Neither Mickey nor Endless turned up tonight.
Wait. She's offline.
So, yes, assuming we could do that, we would solve a lot of problems because, firstly, I could create as much water as I needed. Because as much waste as we generate comes straight back into use. And I just recreate H2O. So that would be an advantage.
You can turn anything into anything, or do you need specific particles to make something into something?
Well, if we're going on a molecular level, as long as I can get 2 hydrogen and 1 oxygen, I can make water. Which in theory means if I knew all of the constituent particles of a cheeseburger and the correct order to put them in, I just assemble the elements into that order and I've got a cheeseburger. Yes?
Well, if you break it down into quantum physics and actually get down to
Yes.
quarks and stuff like that, then everything basically is
Correct.
everything.
That is exactly my point. Now, if you can do it on that level, you're
Hydrogen and a oxygen and well H2O and they're all the same thing.
yes, it's
Essentially.
a proton, a neutron, and a couple of electrons. That's literally it. Yes, correct, 100%. So if we can do it down to the not just the molecular level, but down to the subatomic level, we're home free. Food, water, energy, all of it is sorted in one go.
Any tools?
Anything.
Just sit at home and print yourself a new cell phone.
Absolutely. As long as I had the materials, I'm sorted. Now, for some reason, and I don't know why this is, while I'm just seeing it now, it's funny as hell, so I'm going to share it with you.
You see?
While researching what food would require to be put together, I've got about 20 things on my list of possible things relating to food, and one line which says, but do female astronauts wear bras in space?
No, the bra's probably not needed.
I don't know why that question came up in the midst of, can I molecularly construct a cheeseburger?
Well, I'm guessing some girls still have to wear bras, otherwise they might slap themselves in the face.
I don't know. But why has this connected up to food? I don't know. But there you are.
Probably a strange guy.
Quite possibly. Now,
Strange guy
it
that's
did
got things on his
say,
mind.
brace yourself, to feed one human being in space for one day, it
What?
costs $20,000.
Hi.
Yeah.
Yes.
So if we could make
Well, some is probably more expensive than that because it's a traveling cost that comes into play.
yes, absolutely, that's the main cost. So if you could figure a way to do atomic reconstruction of food, you solved so many problems. I mean, you just re-eat your food and drink over and over and over. So
Don't. Are you saying like you eat and make up and then
You
well,
can eat your own shit.
yeah, you're breaking
what's
every
that?
no, but you're breaking it isn't, because you're breaking everything down to electrons, protons, and neutrons.
I'm not gonna eat my caca.
It wouldn't be there anymore. It would be individual parts of an atom reassembled in a different way, and it would totally not be anything but what it was made
They
into.
turned your caca into a nice,
Okay,
beautiful cheeseburger.
Okay, you are now a scientist, I see. What are you teaching me here?
Well, we're trying to figure out if interstellar travel is anything we will ever be able to achieve.
What is into vanilla now?
Okay, the ability to travel in space, not just to the moon, which is an incredibly short distance, but all the way to other galaxies.
That's impossible.
Yes, I know it's impossible, but could it ever be possible? What are the challenges?
No.
So you
Traveling
think...
to a different galaxy would probably be impossible. But traveling within our own galaxy, even traveling at the speed of light, would take 100,000 years to travel from one
Did.
side of the galaxy to the other side of it.
Correct.
Sorry, 200,000 years. Which
Unless
is,
you use a time machine. I'm so smart.
Well, you're correct, actually, in that time is the problem. Okay, so
Teleportation machine.
food is probably going to be a serious issue. Transportation is going to be a serious issue. What about cloaking devices?
Okay,
Invisibility. Well, it
How would that
is
help?
possible.
why do we need cloaking devices?
So, you know how in Star Trek the Klingons' ship simply disappears? And they go, they've cloaked their ships, we can't see them. So, a device that allows you to render something effectively invisible.
Okay,
who
but
take
I don't
those
think
classes
there's a reason
as
for it.
advantage.
Well,
Unless you've got
enemies.
danger, something that wants to attack you, then it's probably necessary.
And given human nature, there'll be something that wants to attack us.
Or
Be fair.
a pedophile might take the cloak and go into someone's bedroom while they're getting dressed. What?
You have a serious problem. You always bring in pedophiles. I think you've got a bit of a fixation right there. Okay, so cloaking
Think
devices.
aliens visited us with cloaking devices.
Well, cloaking devices are broadly already possible.
Huh?
So, listen up. First point, there are artificially engineered materials with structures smaller than the wavelengths of light or other waves that they are designed to manipulate. They can therefore bend waves like light, sound, or microwaves around an object, making it at least appear as if the waves have passed through empty space. Now, current metamaterial cloaks only work for a very narrow range of wavelengths, so they can cut out specific shades of red or microwaves, so are typically effective only from viewing from certain angles or if the object is stationary. So in other words, they do work, but very badly.
Well, we can still see that.
Oh, I saw that video.
if
It's
I'm-
like
infrared
it's
light,
invisible,
or
but
we can't
it's
see
like
a certain
blurry
range
and
of
all.
infrared light.
If I'm wearing these materials and you're looking at me from the right angle, you can't see me as long as I'm standing still. The moment
in the
I
middle.
move, there
Because
are
I've
issues.
seen some cloaking devices, and yeah, a person can become invisible because the light behind it gets bent,
Yes.
and then you see what's behind it, and still instead of
Correct.
the
Now
person.
we're coming to that because that's one of them. The next system is a lens system. Okay, using a series of lenses like the Rochester cloak, you can bend the light around an object and then back straight again, making it effectively invisible from a continuous range of angles. However, it shows up as a blur if it moves. So it solves the angle problem, but not, you still have to be stationary, and it's fairly big and bulky. So they are bulky, inflexible, and are better actually for seeing around objects. So eliminating a vehicle's blind spot would be a good
I was
thing.
actually watching the movie Predator, or it was called Prey.
Yes.
So this alien has a invisibility cloak.
Yes. Now,
But
exactly.
it's also not completely invisible because they
Yes.
could still see something moving that's invisible.
Correct. Now, the theory, at least in the fiction, is from the third thing. So this is what they call active camouflage, where you have a series of cameras and reflectors all over you, and they're in pairs. So the camera on the front projects the image of what's in front of you behind you, and the camera on the back projects the image behind you in front of you, to effectively make it appear that you're not there. However, if
I
you...
can only see this type of technology being used for military use.
Yes, it is
Otherwise, there's
purely
no other
military.
reason to use it.
Correct. Absolutely correct. But this is what the Predator uses in that movie. So you can see a distortion when it moves, or if the background becomes too complex, it glitches a little. But it is possible. Now, the last kind is brand spanking new, and they don't tell you much about it because it's being developed for its military applications.
Yeah.
All I'm saying is, if they've got it right, they're not telling. However, quantum stealth material. So hyperstealth biotechnology has developed a thin passive material using lenticular lenses that bends light to create dead spots where an object appears to disappear. It's still in the prototype stage, and it's entirely military. So, why do none of these actually fully work? Here is why. Wavelength range. Visible light is short wavelengths, and manipulating all light frequencies and all colors simultaneously is very difficult. Cloaks work better for wavelengths that are comparable to larger than their internal structures. So you would need to create an incredibly fine nano technology type material. That's the problem. Then, light speed and path. Yes, essentially. So light must travel a longer diverted path around the object in the same amount of time as the rest of the light travels straight. This means that the light inside the cloak would have to be sped up faster than the speed of light, so that it arrives at the same time as all the rest of the light, which violates Einstein's relativistic principles, in order for it to be flat as it appears, and you don't get that distortion when something moves. Okay? Viewing angle. Now, most prototypes only work from specific or limited range of angles. If as soon as you step around that angle, you've got a problem. Even the famous Blackbird plane isn't invisible. It's invisible to specific rays, like radar.
Yeah. Well, I wanted to say was that you can probably make something invisible, but you can then also make something to see anything, to see past it.
And
You can
right
look at
there,
radiation coming from that object.
yes, right there is a principle which actually was first told to me by a major security company who said to me, just remember, as fast as you are working to create a better lock, the thief is working on better ways to bypass your locks.
Yeah.
So,
You just
absolute
shine a very
fact.
bright light at it, and then the light reflects back to you, and then you know it's there.
Bam! That's one problem. You are absolutely correct. Now, viewer's perspective is another problem. The person inside the ideal light bending cloak won't be able to see out because we see by incoming light. So there would have to be eye holes. Okay, so you would need so basically I would see a pair of eyes wandering over to me. Now that might still be a very useful thing because eyes being hidden in, say, a jungle is a lot easier than an entire body. And it would be freaky as hell, let's face it. The eyes appear. Da-da!
Yeah.
So,
Well,
yeah.
I
I
was
love...
walking with my camera on in the dark, and then I noticed I can see the cat's eyes shining back at me, like just the
Yes.
cat.
Well,
Horrifying.
you're also... the other thing would be, imagine then again, you're trying to fool different things. What if I could create a thing that at least would be sufficient that I become invisible to cameras? So if I then broke into a place in the middle of the night, nobody's there to see me except the cameras. I only need to be invisible to a camera. Make sense? Just as,
Yes.
just as a blackbird only is invisible to a radar, but given the speed and the height at which it can fly, and it doesn't need to be invisible to anything else. It needs to be invisible to a radar.
Well, it depends on who you're hiding away from.
Exactly. So you have a number of problems. So unless you've got Harry Potter's cloak, you cannot be truly invisible. But you can get damn close, and we're working on it. Good enough, I think, in that regard. So yes, invisibility is theoretically possible by bending light around an object. Scientists have developed methods to cloak small objects using metamaterials and carbon nanotubes and all.
Well,
But
I've seen some of them. Like it's a board. You hide behind the board, and then it
yes,
reflects the light.
that single angle.
Yeah.
Now, a practical invisibility cloak for a human-sized object to be fully invisible is not yet achievable.
Well, that what I was talking about. It's a human size board, but you
Yes,
also have to stand right in front of it, not to see the person behind it.
correct. So you've got two methods of trying to achieve invisibility. Either you bend the light, which is mostly what they're trying, or, like with the active camouflage, you mimic the background. So it creates an illusion of invisibility.
You also have to stand a certain distance away from it to see the person, to not see the person. If you get closer, then you'll start seeing the board.
As well. Now, that in fact might be even scarier. Imagine you're walking down an empty road and 2 feet in front of you, suddenly this guy appears. I mean, right there, you're going to have the shock of your life. I mean, in terms of let's go full Halloween on someone, yeah, they would do it. So you've got passive versus active cloaking. Passive materials don't need power.
There's certain ways how you can still be invisible without using invisibility cloak. Like in the movie, The Prey, where the humans actually went and they caught the predator,
Okay.
and so they outsmarted him. All they did was they digged holes and hid in the holes.
Well,
Let
again,
him step into a bear trap, and then they jumped out and caught him.
in the original Predator movie, what the Predator was doing as well was he was seeing using infrared. And the reason it worked for him is because no matter where you were, you're hotter than your surroundings. So he could see you even hiding behind a tree, which works right up until, I think it was Arnold Schwarzenegger, if I remember correctly. He covered himself in cold mud and therefore disguised his heat signature and stopped being visible. Now, there were scientific issues with that as well, but there again, it shows you the difficulties in both hiding and revealing in these kind of things. It makes it very difficult.
I also probably must tell you about this Predator, this specific movie. He wasn't fully equipped, so he didn't have all his gear. He was kind of like naked.
Yes,
So he didn't have all his technology to be able to see
do
them.
all the good things.
Yeah.
So yes, thanks by the way to Michael Fortuin for the follow there. And guys, do remember, like, share, subscribe, add comments. We rely on you. So give us all of that. But that said, we are going to have to finish the rest in a third live. But what we are going to conclude is, what can we do regarding cloaking? Number one, we can cloak small objects from certain wavelengths. Research is in process because the theory works. They're just trying to figure a way to make it work practically. Now, could it ever be actually done for a person? Well, again, it depends what you're talking about invisibility. Because if you're talking cloaking, yes. If you're talking invisibility, as in somehow you yourself become invisible, the answer is no. But it's irrelevant in that we see...
Got a brilliant idea.
Yes.
No, sorry, it's a stupid idea.
Tell it anyway.
How to be invisible.
Okay.
How to hide away from someone.
Yes.
Just stand behind him.
Well, funny enough, you're actually correct in that regard, because the whole point about sight is that it works on wavelengths of light, and you have to receive them into your eyes to see. So when you're standing behind somebody, you're actually...
You can't see behind you.
Correct. That's exactly the point. So you are outside of the light wavelength, and that's why cloaking might be possible if invisibility isn't, because you're moving yourself outside of the visible spectrum of light. And weirdly enough, that's how green screens work in movies, because they remove from the movie one color green that now you can't see, and everything they want invisible, they make that color green, so then you don't see it in the movie.
Yeah.
So yes. Cloaking, yes. Invisibility, not so much. So
When you see a floating object inside a movie, it's actually a guy in a green suit
yes,
moving the object
literally
around.
walking along, holding it in the air. Yeah, 100%. Now, you can argue it's semantics because if something is invisible from the Latin, it means something which is not visible, as opposed to creating the actual physical body totally transparent. That's a different thing. So we are not talking transparency when we are talking invisibility. We're talking cloaking, making us invisible to sight. So just, yeah, that's really down where that sort of thing is. And it's possible. We can do it to a certain degree. Insofar as. So, yeah,
Have you seen the movie Prey?
I have. I've watched all of the Predator movies.
Except the most recent one, which is the 2025 one. I'm not sure if it's out yet.
It's a prehistoric one.
No. It's involved a humanoid robot.
Okay, no, that one isn't out yet. The last one that was possible to be watched was the one where they went back and it was the early American Indians.
Yes.
Yes.
But to me, it was a bit strange for those Americans, those red Indians, to talk in proper English without any accent.
Well, do you not remember that meme? No, it wasn't just a meme. It was actually in the movie. It was the Robin Hood movie. I don't know if you remember it.
No.
Well, Kevin Costner, if I am not mistaken, played in a Robin Hood movie as Robin Hood. And the whole big joke was that he had a slightly American accent. And they made a spoof of that movie where the actor at one point in the movie says, I might be a second-rate Robin Hood, but at least I have an English accent. And that was the point. So, okay, we are now going to stop for tonight, but in the next live, we are going to discuss something which is currently the biggest argument of all, and I really do expect everybody to weigh in on this. It's AI, time travel, whether or not I can have a lightsaber, and anything else that turns up related to all of this sort of shite in the future.
Okay.
So look
I
forward.
read a tweet from Elon
Yes.
saying that his robots are going to solve poverty. I do not believe that. I
Well,
think his robots are going to cause an immense amount of poverty.
they
All the rich
already
people are going
have.
to rush to go and buy those robots, and they're going to employ those robots, and not people. People are not going to have jobs. They
Well,
will not be able to afford their own robots, and so those robots are not going to solve poverty.
a lot of
It's
the
going to
work,
cause a lot of poverty.
that I do is being done by AI at the place I used to work after I left there, because they thought AI, it's got to be better. And I've read the articles written, they are shit. and I can tell the
They
difference.
might be shit now, but
Well-
they're gonna be experts in every field.
Well, the point is, that's my job gone there.
Yes. And
So they haven't made me
they're
richer.
gonna take every job. And one day in the future, you're rather gonna let a robot do surgery on you than a person. Because it's got
Exactly.
more stable hands.
It's more accurate. Absolutely. So our own sophistication is our own destruction.
Yeah.
But we will get into all of that in the next one. So save something for then. So guys, it is, wow, half an hour past our normal stopping time. Thank you very, very much for being along with. 10 o'clock tomorrow night. Be there or be square. It's going to be another good one. And
Sounds
bring
like a
questions.
good one because I do want to have
A
more
lightsaber.
discussions about AI.
I want a lightsaber. You
Yeah.
know you want one. You know you want one. Don't even lie.
Also, well, let's talk about it tomorrow.
Tomorrow it
I've
is.
got lots of questions about the lightsaber.
There's a lot of problems with it. We will get into them. But until then, guys, have a fantastic evening. Sleep well. Have a good one. And this is me
Good night.
out.
Have a good night.